Ever wondered how hot ice is made? It's quite the riddle, isn't it? Ice is cold, right? So how can it be hot? Well, that's the paradox of hot ice, a substance that's as captivating as it is enigmatic. This isn't your typical ice, folks. This is something that defies our everyday understanding of the world around us. Hot ice, also known as sodium acetate trihydrate in the science realm, is a unique compound that behaves in a way that's so contrary to what we'd expect. It's almost like it's breaking the rules, but don't worry, there's no sorcery here, just good old science. Intrigued yet? You should be, because we're about to dive into the peculiar world of hot ice. We'll explore its composition, the process of making it, and the fascinating chemistry that makes it all possible. So, buckle up and get ready for a thrilling scientific journey. Stay tuned to uncover the secret behind this fascinating phenomenon. Hot ice sounds like an oxymoron, right? But in the world of chemistry, it's a delightful reality. Hot ice isn't actually ice, but rather a substance known as sodium acetate trihydrate. This, my friends, is where the magic happens. Now let's take a quick detour down the lane of chemistry. Sodium acetate trihydrate, a compound that exists in a state of supersaturation, is a marvel in itself. Supersaturation is a state of existence where the solution contains more of the dissolved material than could be dissolved by the solvent under normal circumstances. So you might be asking, what makes hot ice different from the ice in my freezer? The answer lies in the very name itself. When hot ice forms, it releases heat, hence the term hot ice. This is an exothermic process, which is just a fancy term for a chemical reaction that releases heat. In contrast, the ice you find in your freezer is formed through an endothermic process, a process that absorbs heat. That's why when you hold an ice cube, it feels cold. It's actually absorbing heat from your hand. Now, where does this heat come from during the formation of hot ice? It's all down to the sodium acetate trihydrate. When it's in a liquid state, it holds onto a lot of energy. However, when it crystallizes, it releases this stored energy in the form of heat. And here's the kicker. Hot ice can exist at room temperature. That's right, sodium acetate trihydrate can stay in a liquid state even at room temperature. But the moment it's disturbed, it crystallizes and turns into hot ice. So, the next time you hear the term hot ice, remember, it's not just a clever play on words. It's a fascinating chemical reaction that challenges our everyday understanding of ice. So, ready to learn how to make your own hot ice at home? To make hot ice, you'll need some common household items. You might be surprised to know that the magic of hot ice relies on everyday materials. First up, we have distilled water. You can find it in most grocery stores or pharmacies. It's the clean, pure H2O we need for our experiment. Next, we need baking soda, that trusty kitchen staple. It's not just for cookies and cakes. In our hot ice experiment, it plays a crucial role in creating a chemical reaction. Then, we have vinegar. Yes, the same vinegar you use for cooking and cleaning. It plays a starring role in our hot ice recipe, reacting with the baking soda to create our hot ice. And last but not least, you'll need a stove. This is where the heat comes in to transform our ingredients into hot ice. Got everything? Excellent. Now, on to the exciting part. With all ingredients at hand, it's time to start the magic. We've got our baking soda, our vinegar, a pot for boiling, and an eager spirit ready to witness the marvels of science. Let's kick off the process with a bit of a fizzing spectacle. Take your baking soda, about 4 spoons should do, and introduce it to vinegar. Now, watch as they mingle and fizz, creating a chemical reaction that results in sodium acetate. This reaction is the heart of our hot ice experiment, and it's a sight to behold. Next up, we're going to boil this fizzing solution. Why, you ask? Well, the heat helps to purify the sodium acetate, ridding it of any excess water. This step is crucial to ensure that our hot ice forms properly. So pop your solution on the stove and let it simmer away. Remember, patience is key here, folks. You want to boil it down until it's about 1/3 of its original volume. Once you've achieved this, it's time to cool things down. Carefully take your solution off the heat and let it cool to room temperature. This might take a while, so grab a cup of tea, read a chapter of your favorite book, or perhaps ponder the mysteries of the universe. When it's cool, pop it into the fridge for a further 24 hours. This will ensure the solution is super cooled, a vital step in creating hot ice. Now for the grand finale, the crystallization. carefully remove your solution from the fridge. Now, introduce a small crystal of sodium acetate, or even just a spoon that's been dipped in baking soda. Watch as the solution instantly crystallizes before your eyes, forming what appears to be ice but is warm to the touch. And voila, you've just made hot ice. You've witnessed the magic of science, seen the extraordinary in the ordinary, and created something truly spectacular. Remember, the world is full of wonders, and sometimes all it takes is a little bit of curiosity and a pinch of baking soda. But what exactly is happening when we make hot ice? Well, brace yourselves as we delve deep into the world of chemistry. The magic of hot ice, also known as sodium acetate, starts with a simple reaction between two household items: baking soda and vinegar. When these two ingredients meet, they create a bubbly dance of chemistry. The acetic acid in the vinegar reacts with the sodium bicarbonate in the baking soda, resulting in a new compound called sodium acetate, along with some water and carbon dioxide gas. The gas gives us those exciting bubbles, but it's the sodium acetate that's our star player in the hot ice game. But we're not done yet. Our next step is to create a supersaturated solution. In simpler terms, we're going to dissolve so much sodium acetate in water that the water can't hold anymore. And we achieve this by heating the mixture. Once our solution is ready, we let it cool down without any disturbance. The key here is to avoid forming any crystals prematurely. Now here's where the magic, or rather science, really happens. This supersaturated solution is in a state of high energy and is looking for an excuse to crystallize, and we provide that excuse by introducing a seed crystal. The moment the seed crystal hits the solution, the sodium acetate molecules rush to it, attaching themselves in a highly organized crystalline structure. This process, known as exothermic crystallization, releases energy in the form of heat, hence our hot ice. It's fascinating, isn't it? What seems like a magical spectacle is nothing but a series of chemical reactions playing out right in front of our eyes, reminding us of the wonders of science. And the best part? This experiment is safe and simple enough to do at home. Just remember to handle the hot solution with care. So, that's the secret behind the spectacle of hot ice. Before we wrap up, here are some fun facts about hot ice. Did you know that hot ice isn't just a cool science experiment? It actually has some practical uses too. In fact, it's been used in refrigeration systems for decades. Hot ice, or sodium acetate trihydrate as it's scientifically known, can absorb a lot of heat, making it ideal for cooling purposes. And here's a spicy tidbit. Hot ice is edible. Yes, you heard that right. Sodium acetate is recognized as safe by the Food and Drug Administration. It's often used as a food additive to control acidity levels. But remember, just because you can eat it, doesn't mean you should make a meal out of it. Now, if you're still thinking hot ice is some dangerous, unpredictable substance, let's debunk that myth. Hot ice is actually quite safe. It's non-toxic and non-flammable. The exothermic reaction it undergoes is controlled and doesn't cause any explosive effects. So you can have fun with this experiment without any worry. The magic of hot ice isn't just confined to our little planet. It's got cosmic connections too. Scientists believe that sodium acetate trihydrate may exist on other planets and moons, specifically ones with volcanic activity. Imagine that hot ice could be a cosmic traveler. Here's one more nugget of knowledge. Hot ice isn't just hot and icy, it's also a chameleon. It has the fascinating ability to change from a liquid to a solid state almost instantly. This rapid transition is what gives it the seemingly magical properties that we all find so captivating. And there you have it, the mystery of hot ice unraveled. Until next time, keep exploring, keep learning, and have fun with science.